Assalamualaikum and hi to my students. Welcome to the video lecture for technical mathematics for the topic of curve of polar coordinates. At this point, you should be able already to know the concept of basic polar coordinates that is represented by r and theta, which is the angle in radian. R is the distance from the point to the origin 0, 0. So from this given r, we can represent it into several forms that can enable us to sketch a curve. So we start with r equals to 3. So this given example, if r equals to 3, so if we change it into a polar coordinate, then it will be 3 theta. And this time r is fixed at 3 and theta is not given. Let's assume that theta is from 0 until 2 pi. So I will start with 0 first and then proceed to pi over 2 and then 2 pi. So if we plot into this curve, imagine there's a point that moves from the angle of 0 until a whole round of 2 pi circle. So if we try to put 3 here, 3, and this point, the distance between the point with the origin is 3 again. So up until pi over 2 is here, 3. This is a curve from x equals to 3 until y equals to 3. If we move forward until pi, this will be negative 3 here, and if you complete the whole round, it will be a circle with the value of radius of 3. And if r equals to negative 3, we start on the left, but again r equals to negative 3 will also get the same circle. Why not we proceed with the C? Actually, the question should not be sketch the following circles. You will sketch the following curves, right? But let's ignore that. We move to this representation. Still a circle yet, but this time we assign a parameter of alpha, or let's just name it as A. R equals to plus minus A sine theta. So the keyword here, if sine theta, it lies on the y-axis. So let me put a value. For example, r equals to 2 sine theta. And we put x-axis and y-axis. So 2 is a positive 2. So you imagine the 2 is here. And it will be a circle. With a diameter of 2, not a radius of 2. The value of A here can be represented as the distance unit between the value of y until the origin. So 2 will be the diameter. The radius you can assume is 1. The radius of this circle is 1. If it's a negative 2 sine theta, then it will be on the bottom part of the y. So to sketch this, you can imagine this, it will be negative 2 at y and a circle. Not ellipse, circle. Let me try to make this as smooth as possible. Not as smooth. Let me try to adjust the negative 2 here, negative 2 kat sini lah. It will be a circle with a diameter of 2, but this time negative 2 is on the bottom part of y, y negative 2, and the radius will be half of it. But the radius of this circle is 1. That is for the case of sine. If the case of cosine, so R equals to cos, saya letak 2 cos theta. Okay, 2 cos theta, cos you try to represent at the x-axis, so 2 here, this is cos theta. You sketch the circle on the x-axis because 2 is positive and it will be on the positive x, and vice versa. You get the picture already. If negative 2 cos theta, it will be at the negative 2, and then still the same principle. The diameter is 2 and the radius is 1. Let's go for the case when theta is fixed but the r is not. For the case of theta, where the angle is fixed, okay, this is pi over 4. Can I change to pi over, let theta equals to pi, because the example is on the left right now. So in this particular case, r is arbitrary, and theta is pi. Okay, sketch the given polar coordinate r and pi. So you happen to know that pi, the angle from the horizontal axis up until pi, will be here. So why I said the r can be arbitrary? So if I sketch this will be 1. So for example, this is 2 and this is 3. So actually, if the angle is fixed, then it will be a straight line here, as such that the angle, oh no, this is pi, so pi is 180 here. Okay, I retract pi, so imagine is the pi is fixed, 1, 2, this is negative 1, negative 2, and negative 3. Okay, this will be represented by a straight line here, such that the angle is fixed at pi. This is pi, this is pi, this is pi. Then the straight line dia kat sini is parallel with the x-axis. Okay, this one you can read it on your own. If we assign r equals to theta, it will be a spiral. Okay, this is quite visual. It's very hard to sketch it, but yes, because the theta is unfixed there, then it will be spiral. If you right now, just now we already agreed that a circle, the standard form, it will be plus minus alpha, a cos theta and sin theta. So sin theta ni ini dekat y axis. If plus minus a cos theta, the a will be at the x axis. It can be whether on the top or on the bottom for the sine, cos right or left. This is a special form of a curve known as cardioid, or a heart shape. Bentuk dia macam heart. Okay, so cardioid has plus minus a, it will be a parameter a plus minus you assign another value. This time is b sine theta, and also it can be a plus minus b cos theta. Again, the same principle. If the sine, then the value on the later I will show you on how to plot it. Okay, let's look at the first example. This one is a curve on a normal standard trigo punya line. Theta kita plot dengan paksi R. Ni bukan XY lah, dia akan jadi macam ni. Tetapi okay, I want to show you for the case of R1 plus sine theta and how it can be a heart shape there. Okay, in the form of a Cartesian xy axis, you start first when theta is 0. Okay, please refer to the table. If theta equals to 0, then the R will be 1 plus sine theta. I think I should write the table here so that it can help us to measure it, to visualize it better. Kosong pi over 2 pi 3 pi over 2 2 pi 1 plus sine theta. I add up one more column here, sine theta, then I put R. So sine theta, sine kosong kosong 1, sine pi kosong, sine 3 pi negative 1 and 2 pi kosong. So you add with 1, 1 tambah 1 2, 1 0 and also 1. Okay, now we can sketch. Okay, we start first when R equals to 0. Then the distance between the point with the origin is 1. So saya letak 1 kat sini. Pada angle kosong. When the angle is pi over 2, it shifts from the origin until 90 degrees or pi over 2 in radian. It will be 2. Okay, so we curve the movement from 0 to 2. Okay, it will not be as beautiful as on the left. If we move pi until degree pi, okay, then the coordinate, the distance is 1 as well from the origin. Now comes the interesting part where R becomes 0 for the case of 270. 3 pi over 2, the distance of R will become 0. So the curve moves to 0. And if we complete the whole until 2 pi, then the distance become 1 back. So it will become a cardioid or the heart shape. But please sketch it more beautiful than me. Okay, let me show you for the case of 1 plus cos theta. Okay, for this particular case, I would like to challenge my students to plot where the case of we try to have a theta first, theta 0, theta pi over 2, pi, 3 pi over 2, and 2 pi. You try to find the cos theta and you try to find R. R adalah 1 plus cos theta. Try to calculate it first. You may pause the video. Now I hope you get this value based on your you try to complete the table. Now we try to plot this 1 plus cos theta. So it starts from when the angle is 0, the r, the value from the origin is 2. So saya letaklah 1, 2. This will be the mark here. When pi equals to 2, it's dipped down to 2, to 1. So jadi macam ni. When the angle is pi, then the distance from the point will be 0. When 3 pi over 2 is 1, and it goes back to 2. It will be on the heart shape, but on this representation. So this is 1 plus cos theta. Now it will be on the heart shape where the large part is on the right. Okay, later we will do more examples and I will explain it more on the different given function of R during our live session. So let's look at the case of the symmetricness, or we call it ray symmetric test. There are two forms of ray. The common form, ray theta is 0 or ray theta is pi over 2. The concept of ray is very easy to understand where you measure the line. You know already how to measure the angle. Kalau kita kata theta sama dengan kosong, it means that the symmetric of ray, the symmetrical line will be at the horizontal of the x-axis. So if ray theta equals to 0, it means that the symmetric axis, the symmetric line, is x-axis. If pi over 2 or 90 degrees, then 90 degree, you plot lah 90 pi over 2. This also means that the symmetric line is on about y-axis. Okay. If you mention that ray theta equals to other theta, then it will be a straight line at the given angle. Now let's start with a simple one. Maybe we discuss only these two, and if we have a different ray theta is another value, then we mention it during the last session of the class. Okay, how to show that it is similar first? We define it is symmetric if r theta equals to r negative theta. So kita letak di dalam bentuk function. F theta should be equal to f negative theta. So let me visualize first. Okay, if the ray is 0, so ke x-axis lah. Okay, imagine there's a point here. Okay. Okay, if it is symmetric with ray theta equals to 0 or x-axis, this is the angle here. Where will be the symmetric point? Imagine again the x-axis become your symmetric line there. So cermin dia, they will be here. This will be negative theta. Theta clockwise, anti-clockwise, negative theta, anti-clockwise. So if you manage to prove that f theta equals to f negative theta, so it means it is symmetric during ray theta equals to 0. Okay. Now, let's try to go to the case where ray theta is at the y-axis or ray theta equals to pi over 2. Sekarang ni ray kat sini. And you try to put the theta here, this point. The mirror is at the ray theta pi over 2, the blue color part. So it will be here. Now, the angle here will be from the line here. Okay, how to get the value here? Just you get pi minus theta. So if you manage to prove that f theta equals to f pi tolak theta, then it means it is symmetrical at the ray pi over 2. It is symmetrical at the vertical axis y. So let's go to the example. Okay, given the value of r is 2 cos theta. Okay, try to recall back what will be the basic shape of 2 cos theta. Okay, so it will be a circle on the cos theta dekat x-axis. So you boleh imagine you punya circle dekat mana? Dekat kanan. Okay, tapi that is not the question. The question is that show that the curve is symmetric at the ray theta equals to 0. So ray theta equals to 0, show symmetric at ray theta equals to 0. Okay, my hint is that it will be the symmetric line of x-axis. Okay, so if ray theta equals to 0, you need to show, in other words, that f theta equals to f negative theta. Okay, if f theta is 2 cos theta, what will be f negative theta? It will be 2 cos negative theta. Okay, there will be a trigonometric properties involved here. You can try to see at the properties that cos theta is actually similar with cos negative theta. Therefore, it will be 2 cos theta. From here, I managed to show that f theta by using trigonometry identity cos theta equals to cos negative theta dia sama, maka f theta equals to negative theta. So shown actually based on this simple proof by using this property that actually they are similar. So yes, it is symmetric at ray theta equals to 0. Now you need to plot it. Plot curve from 0 theta only until pi over 2. So you may pause the video before you get the actual sketch. If you are not sure, you can also use the table to give you the idea. Here, so theta cos theta dengan r is 2 cos theta. Right now it only asks for 0 and also pi over 2. If I want to make more sure, it will be pi over 4 here. Okay, so cos theta sama kosong ialah 1. Pi over 4 is square root 2 over 2. And also this one will be 0. You multiply with 2, this will be 2 square root of 2 and also 0. Okay, this will be a little bit brief idea that I happen to know if the degree is 0 here, then it will be at 2. Okay, then when the degree is 45 pi over 4 or 45 degree here, then it will be somewhere around here. And if you complete the degree of 90 of pi over 2, it will be 0. So you akan dapat curve, circle sampai semicircle sini, because it asks only for pi over 2. Okay, use the symmetric property to sketch the whole curve. Just now this question say the ray theta is 0. So dia punya symmetrical line dekat x-axis sini. Use the symmetric property. Okay, you dah ada semicircle kat sini. You lukis dia punya mirror dia. Okay, you try to sketch if the reflection of it at the x-axis will be the complete circle there. Okay, sketch this nicely. I'm having a hard time to sketch on this. Dia jadi bulatan ya. Dengan diameter 2. Okay. Okay, let's move on. Okay, this slide is similar with my previous solution just now. I just explained it one by one. For this particular case, it extends for pi over 6 and pi over 3 also. I just do 0, pi over 4, pi over 2. And if you use the symmetric line at ray theta equals to 0 or x-axis, then you will get the whole circle there. It will be like that with the diameter 2 and the radius will be 1. I strongly advise you, if you need to draw the curve, you use the protractor. Okay, let's move on to the exercise. This exercise we don't have the solution there, so I will write the solution on this video. So this time, the given polar equation R is 2 plus 2 sine theta. Okay, this basic form give me that this curve is a cardioid. Okay, but the question right now, the first one is that you need to show that it is symmetric with ray theta equals to pi over 2. So dia dekat y-axis. So get this idea first. Okay, if pi over 2, then you need to show that f theta equals to f pi tolak theta. So try to find if f theta equals to 2 plus 2 sine theta. And what is f pi minus theta? Okay, then you replace it inside, it will be 2 plus 2 sine pi minus theta. Okay, I will use the supplementary identity. Pi minus theta equals to 2 plus 2 sine theta. You can also use the sine a plus b, a plus minus b equals to sine a cos b minus cos a sine b. You can also use that some identity, but I found a simple one which is supplementary. Okay. Okay, it is actually similar to this. Sine pi theta minus theta. Let me write the identity. Sine pi minus theta is equals to sine theta. This is much more simple. Therefore, it is concluded that f theta is actually equals to f pi minus theta. So it is shown there. So it's important for you to actually know the trigonometric identities. You already learned it during basic mathematics and calculus, I suppose. Okay, now comes the major question, is that you need to plot it from negative pi over 2 for theta until pi over 2. So my suggestion again, if you don't have the idea, why not you use the table to plot it first. So theta 2 sin theta, or you can start first with sin theta, 2 sin theta, then you proceed with r, which is 2 plus 2 sin theta, and theta starts from negative pi over 2. I can negative pi over 4, then 0, pi over 4, and pi over 2. Okay, you can pause the video before you get the actual if you want to confirm it with my answer. Okay, so if you do this one by one, this will be negative 1, negative square root 2 over 2, 0, square root 2, 2, no, 1. And you add up with, you multiply with 2, negative square root 2, 0, square root 2, 1 times 2, 2. And r will be 2 plus 2 sin theta. Then it will be 0, 2 minus square root 2. This will be 2, 2 plus square root 2, 4. Okay. As this is a cadiode, so we try to sketch this. Okay, we start at negative pi over 2. Negative pi over 2, negative 90 degrees. So starts here on the left. So if a negative pi over 2, the value of r from the origin is 0, so you start here. Then when negative pi over 4 or negative 45 degrees, it moves to somewhere at the radius of here. When 0, you pergi 2. Okay. When angle 0. When angle is pi over 4 or 45 degree, somewhere around here where the value of r is 2 plus square root 2, and it ends at 4. So I sketch 4 for 1, 2, 3, 4. The curves is until 4. Okay, let me draw in a different color. Oh, it's become worse. Let me draw that again. I try to smooth a line there. Okay, this is smooth that I can get. Okay, sini 4. Okay, that's all. Because it's until pi over 2 only. So by using the symmetric property, where is the ray? The ray is at pi over 2. So ray dia kat sini. By using the symmetric, then you can continue the line here. This one in negative 2. Back to 0. It will be a heart shape with the shape like this. Alright, I think that's all about the first 3 curve of polar coordinate. You know first on how to plot it. Know the basic form first. You have line, straight line. You have a circle, alpha plus minus cos or sine, and then you must know the basic form of cadiode. And then you proceed with know on how to use the symmetric properties of ray theta you have to rate theta equals to 0 and also rate theta equals to pi over 2. We will continue more on our live session, and until the next video you will try to use this curve and to find the areas in polar coordinate. See you on the next video.